In this video, we will see how to add two signals using an op-amp. Here is a circuit which can do this. First, let's recall some basic principles of op-amp circuits from our previous videos. We need two key properties. One, if the op-amp is not in saturation, there is a virtual short between the inverting and the non-inverting pin. In circuits such as these, where the potential at the non-inverting pin is 0, we can assume the potential at the inverting pin to also be 0. There is no current going into the inverting or the non-inverting pin, that's point 2. This is why the potential at the non-inverting pin is 0, even though there is a resistor between it and the ground. Now, the basic principle is the following. Due to the virtual ground, the current at the input size is independent of what's in the feedback loop. Since the same current also flows through the feedback loop, the feedback loop controls how this current is converted into output voltage. Since we want to add two signals, this can be accomplished by making the current through the feedback loop proportional to the sum of the two input voltages. To see how we can do this, consider this simple circuit where we have two voltage sources connected in parallel through these resistors to the ground. We can easily see that the current going into the ground is as follows. If R1 is equal to R2, then the current will be proportional to the sum of the voltages. Otherwise, it will be some weighted combination of the two voltages depending on what these resistor values are. Note that this is exactly what this part of the circuit is doing. The analysis remains the same due to the virtual short, and the current goes through the feedback loop instead of into the ground. The output is therefore proportional to the current, which is a weighted combination of the two signals. Now pause this video and figure out the following. What if I wanted a weighted combination of 3 signals instead of 2? How would you modify this circuit? Note that in the circuit considered, we can only have negative weights for the signals. What if we want some of the weights to be positive and some to be negative? An easy way, in terms of analysis, would be to consider 2 stages of op-amps. Since we know each stage computes negatively weighted combinations, we need to pass the signals for which we want positive weights through both stages and those with negative weights through one of them. It then comes down to calculating the proper resistance values to get the weights we need. A common mistake when connecting the 2 stages is to connect the output of one op-amp directly to the inverting pin of the next. Again, pause this video here and figure out why this is a mistake. Now finally, a challenge question to you all. There is a way to do any arbitrary weighted combination that is both positive and negative weights using just one op-amp. How would you do this?